we are starting in 7.2. We're just going to continue on with basically what we did from 7.1. We're just going to get a little bit more familiar with these guys. There's going to be some new things that pop up today, but the concept should still be very, very similar to what we've talked about in the previous lesson. So, remember, I'm going through the teacher edition, so the answers are on here just written in so to make it a little easier. So here we go. All right, so for these guys, they're asking, consider the table below. Identify the vertical asymptote, horizontal, domain, range for the given C values. Then choose different positives and see, fill this in on your own. So what they're doing is they're just showing you, if you have this down here, in order for a vertical asymptote, remember vertical asymptotes are where your denominator is 0. If you plug in a 1 into this right here, 1 minus 1 is 0, making your denominator 0. That's why your vertical asymptote is x equals 1. For horizontal asymptotes, that's the m and n. When your bottom power is bigger than your top power, which the power in the bottom is 1, the top power is 0, my bottom power is bigger than my top, it's always y equals 0 is your horizontal asymptote. Now, for the domain and range, your domain is going to deal with your vertical asymptote, because that's going to be an x equals. Your range is going to be affected by your horizontal and which way this thing is facing and the stuff that we talked about yesterday in class. So since I know that this thing is, it's going to be all reals except, for my domain, it's going to be all reals except x can't be 1, because that vertical asymptote. So if I draw a picture of this real quick, it's going to look like this, where x equals 1 is going to be my vertical asymptote, and this line right here is my horizontal. And I know that since it's odd, one is going to be down and one is going to be up. And if I think about this, if I put in a 0, for x, my y chart, if I put in 0, 0 minus 1 is a negative 1, 1 over negative 1 is negative 1, so I get 0 and negative 1. So it shows me that this is the bottom side, and remember, if I'm an odd, I know 1's in the bottom, 1 has to be up top. So this part over here is going to be my top side, just to check to make sure. If I put in 2, 2 minus 1 is 1, 1 over 1 is 1, so if I put in 2, I get a 1 out. And so I can see that that is my graph, and I know that it's all reals except for y equaling 0 for my range, because this thing goes up forever, it goes down forever, but it's never allowed to touch this. So for these guys right here, again, what's my bottom becoming 0? A negative 2. That's my vertical asymptote. I know y can't equal 0 for my horizontal because my bottom is bigger than my top power. And again, my range is going to be, my domain is everything except for 2. And my range, because it's odd, I know that it's going to be all reals except for 0. If it's even, I know it's either going to be greater than, I know that if it's even, I know it's either going to be y is greater than or equal to 0, or y is less than or equal to 0, depending on whether it's up or in the bottom. So we're going to study some of this stuff. So determine the general formula for this. So we've already done this. Basically, here, let's do, let me switch to this one. All right, so I switched to the other yearbook. So without using calculator, determine the domain, range, vertical asymptotes, horizontal asymptotes. Actually, I'm going to do the vertical and horizontal asymptotes because I think that those help me dictate the domain and range much easier. So my vertical asymptote, what makes the denominator 0? That would be x equals 0. It's not allowed to happen because if I put a 0 in here, my denominator becomes 0, no bueno. Horizontal asymptote, my bottom power is bigger than my top, so y equals 0. I know this is odd, so since it's an odd power, I know my graph is going to look something like this. And since this is positive, if I put in a x and y chart real quick, if I put in a negative 1, 10 over negative 1 is a negative 10. So if I go here, it'd be a negative 10. It's going to be way up there somewhere. But I don't really care about that. I just care that it's up there. If I put in a positive 1, I kick back a, whoops, negative 10. So I lied. Not my fault. Try this again. If I make an X and Y chart, if I put in a negative 1, I kick out a negative 10. So I know my graph is going to be different here. If I put in a positive 1, I kick out a positive 10, and then I know my graph is up here. And so I can see one's in the top, one's in the bottom. That means my domain, X is allowed to be everything. Alright, so now looking at my X, my domain already says X. I know that it's going to be all reals, except X is not allowed to equal, if I look, it's that vertical asymptote, it's not allowed to equal 0. I look at my Y's, this thing goes down forever, so it goes to negative infinity, it goes up forever, it goes to positive infinity, it just isn't allowed to be this, so I got all reals, except Y cannot equal 0. Alright, now look what happens here. Watch what happens when I have this guy. Okay, I know my vertical asymptote is where my denominator is 0, so my vertical asymptote is going to be X equals 10, negative 10, sorry. Because if I put a negative 10 into here, negative 10 plus 10 is 0. Boom, not allowed to happen. My horizontal, my bottom is still bigger than my top, so it's Y equals 0. So it means my domain is all reals, except X is not allowed to equal negative 10. And I know my range is, since it's odd still, I know it's going to be all reals, except Y can't equal 0. And I know that it's going to, one is going to be up and one is going to be down. I don't care if it's this one and this one, or if it's going to be this one and this one. I know that one's down and one is up, so I know it's going to go to positive infinity and negative infinity. This guy right here, this one's tricky. My vertical asymptote, there is none, because there is no way for my denominator to be 0. My horizontal asymptote, there is no horizontal asymptote, because my top is bigger than my bottom. When my top is bigger than my bottom, there is no horizontal. My domain is all reals. My range is all reals. There are no spots that this can't be. This, in fact, is a linear equation of x equals, or 10x plus 0. So it would be 0, 0, and then my rise would be 10 over run. So I'd go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1. And so my graph would look something like that. This guy right here, my vertical asymptote would be x equals 10, and my horizontal would be y equals 0. Again, my domain would be all reals, except x cannot equal 10. All reals except y cannot equal 0. And remember, it's because the range, because it's odd down here, I know that this is going to be one's up and one's down. All right, write the rational function for the table. Describe what is your reasoning. So for this one, I know that it's going to be odd. I know it's odd, so my bottom has to be odd. And I know that it's got to be, so it's going to be x. And since this is negative 4, it's not, this is my asymptote. This would have to be plus 4 down here. Because when I put in a negative 4, negative 4 plus 4 equals 0. That's where I want my denominator to be 0 when I put in negative 4. So it's plus 4. And then up top, it really doesn't matter. You can put 10, you can put 5. You just cannot put an x up top. You cannot put an x up top, because if I put a 10x up top and an x plus 4, my power is 1. My power is 1. That would change my horizontal asymptote. So that cannot happen for this one. Just for later on when we get to these things. All right, vertical asymptote at x equals 3. That means that x minus 3 has to be in the bottom, because if I put in a 3, it makes it 0, so it's x minus 3. And an asymptote at this, so again, my bottom has to be bigger than my top power, so I have to do like a 5 here. Something like that. Alright, so let's move on. Alright, so what determines the vertical asymptote? What determines the vertical asymptote is the denominator. Do you think that a rational function could have more than one vertical asymptote? Yes, it can. And as long as the denominator becomes 0, and we're going to get to why what that would look like where it has more than one, it can have more than one vertical asymptote. So here we go. Without using graphing calculator, sketch a graph of this. All right. So my vertical asymptote for here is x equals 0. So I'm going to dot that. My bottom is bigger than my top, so it's y equals 0 is my. So these are asymptotes. Now I need to figure out whether it's here, 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 and I know it's going to be it's either going to be up top and this is going to be bottom, or it's going to be bottom and this is going to be top because it's odd. I know one's one and one's the other. So I put in my x and y chart real quick. Pop a 1 in. 1 over 1 is 1. So if I go 1, 1, it would be here, which means this is there, which should mean that this should be here. And I can check that real quick. If I put in a negative 1. If I put in a negative 1, 1 over negative 1 is negative 1. So again, it looks like negative 1, 1. And I graph this off a little bit, but there we go. So there's a quick sketch. All right, this guy. Where is my vertical asymptote? My vertical asymptote is x equals 2. So it's actually going to be over here. My bottom is still bigger than my top, so this is my horizontal is still y equals 0. And if I try this, I make an x and y chart. Now, be careful of my numbers. When I do this, my numbers I'm going to pick for x, since it's 2, I want to pick a number bigger than that. So I'm going to pick 3. 3 minus 2 is 1, and it's odd still, so I know one's going to be up, one's going to be down. 1 up, 1 down, 1 up, 1 down. Doesn't matter which one. I'm going to figure that out by plugging in. 3 minus 2 is 1. 1 over 1 is 1. So 3, 1 means that this is over 3 up 1. I know this graph is up here. If I put a negative 1 in, I'm sorry, I don't want to put a positive 1 in. I just want to go a little bit to the left of this asymptote. So negative, or a positive 1. 1 minus 2 is a negative 1. 1 over negative 1 is negative 1. So I know it's 1, negative 1. I know this graph, like I said, is down here. So there's a quick sketch of that graph. Alright, these guys are even, so I got to be careful on these. This right here, I know my x equals 2 is still my asymptote. I know that it's y equals 0 is the other asymptote because my bottom power is still bigger than my top, but I see that this is a squared here. Since it's squared, I know that no matter what happens, whenever I put in a number in here, even if it looks like it makes it negative, the square is going to make it positive, which means both my graphs are going to have to be up in this region. Just check it, x and y. If I pop in a negative 1, actually no, remember we said we want to be closer to the asymptote. It makes it just easier. Pick easy numbers. So since I'm going to be close to the asymptote, I'm going to put a 1. 1 minus 2 is a negative 1, but negative 1 squared is 1, and 1 over 1 is 1. So if I put in a 1, I get a positive 1 out. Well, watch what happens if I put a 3 in. 3 minus 2 is 1, 1 squared is 1, 1 over 1 is 1. So I put in 3, I get a 1 out. So again, both of these are in the top. So a quick sketch of that is like that. Remember, when they say sketch, they're not asking for perfect. Now, the reason I knew that both of these were up is because my top was positive. Well, when I look here, I've got a even power, so I know they're either going to be top, top, or bottom, bottom, and this is negative. So I draw my asymptotes, which my bottom equals 0 is going to be x equals 2, because if I put in a 2 there, that makes it 0. That's an asymptote. My bottom is bigger than my top, so y equals 0 is the other asymptote. And I know since this is negative, they're both going to be in the bottom section. So I know this is a quick sketch of these graphs. I know that's what it should look like. That's not perfect, but if I was going to do these guys, let's go to this one. If I was going to do this guy right here, I was going to do this guy. Positive. So this is actually my asymptote is x equals negative 3. So put in a negative 3. Negative 3 kicks out a 0 on the bottom. Not good. Bottom's bigger than top still, so My asymptote is going to be like this, X and Y chart, just to make sure. Since this is positive and this is odd, I believe that this is going to start down. And this one's going to be in this region, and this one should be in this region. On the so then I go, okay, let's make sure that I'm correct. Close to the asymptote, -4. -4 plus 3 is -1. -1 cubed is -1. -1 divided by 1 is -1. So if I put a -4 in, I get -1. Boom, that's the region I thought it was supposed to be in. All right, try just on the other side of it, try -2. -2 plus 3 is 1. 1 cubed is 1. 1 over 1 is 1. So if I put in a -2, I get a +1. And again, that's what the region I thought it was. There's a quick sketch. All right, this one. The asymptote again is x equals -3. Because if I put in -3, it makes the bottom 0. No bueno. Now this is a negative up here. So I think that this, y equals 0, still my other asymptote because my bottom is bigger than my top. So I think since this is negative, instead of being down and then up, I think it's going to start in this one and end over here. Or the first one's going to start in the top, the second one's going to start when I have two pieces. So here we go. Check that to make sure that that's correct. Just quickly pop in numbers. -4. -4 minus 3 is -1. -1 cubed is -1. -1 over -1 is a +1, and it kicks out a positive like I thought it would. -2 and a 3 is a -1, or a +1. 1 cubed is 1. A -1 over +1 is 1, and that's a -1, I'm sorry. -1 over +1 is -1, and that's what I thought it would be down in this region. So there's a quick sketch. That's all you need to do for sketches. All right. Now here we go. Here are some of the things that we really need to get into this lesson. Now on the bottom, notice I've got x squared plus 4. If I want to find, my vertical asymptotes, I need to make the denominator 0. So that means that x squared plus 4 equals 0. Hopefully you're realizing, in order for me to do this, I'm going to have to factor this. I'm going to have to factor this, or I'm going to have to use one of those, solving for, move the equation around. So actually I'm going to try the first way, or the second way. Move the equation around. So x squared plus 4, I need to make that equal to 0. Minus 4, I get x squared equals a -4. Hopefully we realize right here, you cannot have a number squared and kick out a negative. So what do I know? There are no solutions to this. No solutions, which means if there's no solutions, that means there's no way for my denominator to become 0. So there are no vertical asymptotes. No vertical asymptotes for this question. All right, now for this one, I need x squared minus 4 to equal 0. Well, hopefully you realize right away, hey, this right here is a square root. This right here is a square root, and this is a subtraction sign. Mr. Martin has said over and over, you need to learn to factor, and this is called a difference of squares pops up. X plus 2, x minus 2. So in my bottom, I can actually rewrite this question as 4 over x plus 2 and x minus 2. And what numbers would make this 0? Well, a -2 would make that 0, and the whole thing would turn to 0, or a +2 would make that bubble 0, which would turn the whole thing. So x equals -2 or +2. So that means I actually have two vertical asymptotes for this question. X equals 2 is one of my vertical asymptotes, and x equals -2 is another vertical asymptote. And so actually this graph, which we're probably going to get into a little bit more, would have two vertical asymptotes. At -2 would be a vertical asymptote. At +2 would be a vertical asymptote. And my bottom power is bigger than my top power, so x equals 0 is my other vertical asymptote. And then I'm going to have either a piece. I'm going to have three sections to this graph. This is section from here, here. This is one section. This is my second section, and this is my third section. Remember, either it's going to be here or here, here or here, here or here. So I'm going to have to figure out which one in each one of these things that belongs to. And again, we're going to get to there later on. All right, my number for part C says for me to find the vertical asymptotes. Again, this is just asking for vertical. I'm just going a little bit farther just to try to make some connections for later on. So here we go. This says vertical asymptotes, x squared plus 4x plus 4. I need to see when u equals 0. Well, in order for me to do that, I'm going to have to factor. Well, I realize, hey, this has a square root, which is x. This is a square root, which is 2. This times this is 2x times 2 is 4x. We have a perfect square. X, 2, and squared. This says same sign, so I know they're same signs because they're perfect square. And this is a plus, so I have to put a plus in here. So x plus 2 squared equals 0. So actually, there's only one asymptote. The asymptote is x equals, what number would you put in here to become a 0? Negative 2. So x equals negative 2 is my only asymptote for this one. All right, Sarah determines the vertical asymptotes for this. The first thing that we need to do is, let's check her work. First, she realizes, hey, all these have a common factor, which is 2. She factors that out. She's left with x squared minus 7x minus 8. Then she says, okay, this is the easy one. I can double bubble right away. The reason I can double bubble right away is because I have 1 right here. I need two numbers that multiply to 8, but different signs, so subtract to a 7. That would be 8 and 1. The bigger number is negative, so I get x minus 8, x plus 1. And that means my asymptotes are x equals 8 and x equals negative 1. So I got two asymptotes. She says that, therefore she's going to be correct. I think this is, all right, this is our last section, so we're almost done. Hang in there. All right, this one right here. In order for me to use these, it says use algebra to determine vertical asymptotes. I need to see where my denominator is 0. So this guy right here, I say you need to, if it's not factored, you need to factor it. So 7x minus 35, we're going to manipulate that. Both of these have a 7 in common. What am I left with? X minus 5. Does this part ever make a 0? Can 7 ever become 0? No, it's a constant. So I don't have to worry about that part. Can this become a 0? Yes. What if you put in a 5? So x equals 5 is my vertical asymptote because 5 would make my denominator 0. Check it. 7 times 5, if I put in a 5 here, 7 times 5 is 35. 35 minus 35 is 0. And not allowed to have vertical asymptotes. Okay, right here, it's already factored for you. So x equals, can this ever become 0? Yes, if x is 0. And if this is 0, then 0 times anything is 0 times anything is 0. So x equals 0 is one of my asymptotes. X equals, well, what would I put in here? A positive 2. And x equals, and this one right here is a little trickier. 2x plus 3. If you can't see where it equals 0, set it equal to 0. Minus 3, minus 3. 2x equals negative 3. Divide by 2, divide by 2. X equals a negative 3 halves. So that would be my other. So this one actually has 3 asymptotes. That is perfectly okay. Part C, what I'd have to do is I'd have to factor this guy, and I realize that this is perfect, or this is, I can double bubble right away. Check for perfect square. No, that doesn't have a square. 10 doesn't have a square root. No, it's not a difference of squares. So I just double bubble right away. Different signs. One's positive, one's negative. Bigger number is going to be with the negative. Two numbers that multiply to 10 but subtract to 3. X, x, and I know 5 and 2, and the bigger number goes to the negative, so 5 and 2, which means my asymptote is x equals negative 2. And x equals 5. Those are my asymptotes. So if I was doing that on a graph, it'd be negative 2. I'd be drawing a dotted line, and at 1, 2, 3, 4, 5, I'd be drawing a dotted line. and also a horizontal asymptote because my bottom is bigger than my top. Hopefully we're getting this. All right, this one, a little bit more pain in the butt because I realized, oh crap, I don't have a greatest common factor. There's a 2, so I have to go, okay, let's manipulate this guy. 2x squared plus 9x plus 4. You remember, if this is not a 1, you have to multiply 2 times 4, which is 8. That is my number I'm trying to get to. I need 2 numbers that multiply to 8, but add same signs to a positive 9. So it would be 2x squared plus 8x plus 1x plus 4. Double bubble, or group by factor by grouping. What do these guys have in common? They have a 2 and an x. I factor out a 2x. I'm left with x plus 4. Well, that's great, because back here I already have a x plus 4. What does this have in common with this? An x plus 4. So I factor out an x plus 4. What am I left with from the first part? A 2x. What am I left with back here? Plus 1. So my asymptote is x equals negative 4. That's from this one. And from this one, if I can't see it right away, I just go 2x plus 1 equals 0. Hopefully you're seeing how much work I'm showing. Minus 1, minus 1. 2x equals a negative 1, divide by 2, divide by 2. X equals a negative 1 half. X equals a negative 1 half. So let's try this one. X squared plus 2 equals 0. Remember, you don't have to factor this. If you try to factor it, you're going to realize this is not a difference of squares. Even if I minus 2 over here, I get x squared equals a negative 2. We can never have a negative. We can never square something and kick out a negative, not in the real number system. Those are called imaginaries. We did those at the beginning of the year. So this is going to have no vertical asymptotes. This one right here. Alright, this is the last one I'm going to point out and we're done. This one right here is tricky, and we're going to get into that a lot later on. But this right here is that idea of, I think in some classes I talked about a hole. Because these guys actually cancel each other out, which we're going to get into a lot later on, this is no vertical asymptote. There's what this thing is called a hole. Because you have the same thing in the top as you do in the bottom and it cancels out, you do not have a asymptote. You have what is called a hole. So you still, x cannot equal 2 in this equation. But it doesn't create a vertical asymptote. It creates an idea of a hole. So what's going to happen is this graph might look something like this, and all of a sudden when x equals 2, there's a hole, and then it continues on. Again, like I said, this is just previewing something that we're going to get into much later on. I don't know why this book throws that in there, but we'll get into this idea a lot more later on. But there is a hole that happens because of this. So there is actually no vertical asymptote. I know some of you are thinking it's at 2, but that's because the top also has that same factor in it that they actually cancel each other out. Same with this guy right here. If I look at h, the actually only vertical asymptote is x equals 5. This guy right here and this guy right here, since they cancel each other out, yes, x can still not equal negative 2 in that equation, but it's a hole. This is a hole. Because these guys cancel out. It is not a vertical asymptote. Whereas this guy, since it doesn't cancel out, is a vertical asymptote. All right. Have a great night. Thank you.